In this video, we will go over some of the introductions that we have previously learned in trigonometry. So whenever we talk about trigonometry, the one main aspect or the one main parameter or the one main thing that we always look in trigonometry is the angle. And this is a very key factor in trigonometry. So whenever you're measuring an angle in trigonometry, you measure it in this direction, which is in the anti-clockwise direction. So this will be your initial side and this will be your terminal side. As the terminal side rotates, even if the initial side rotates, your angle will be measured from the initial side to the terminal side in the anti-clockwise direction. You may be all familiar with this right angle. This is a very common angle that you would have used in triangles, or if you're talking about a rectangle, then you would say that one of its property is the angles are right angle. So you are familiar with right angle. Did you know to measure this right angle, we have a system called the sexagesimal system, where this right angle is divided into 90 equal parts called the degrees. I'm sure now you're getting familiar. This is a 90 degree. Yes. So we got this 90 degrees from the sexagesimal system. And each part of a degree is further divided into 60 equal parts and it's called 1 minute. And each of this minute is further divided into 60 equal parts of seconds. So you write the degree with this symbol here, and then the minute with this with a dash, and then with the seconds with a double dash. So this system is called sexagesimal system. This is the common use system in trigonometry. However, you have other systems, a system which is centesimal system. And in this system, this right angle is divided into 100 equal parts and it's called grades. And each of this grade is divided into 100 minutes and each minute is further subdivided into 100 seconds. The symbol for the centesimal system is, or the grade is 1G, like this. Okay. The next one is also a very widely used measure, which we would look more in detail in the further chapters. But now, just for an introduction, this is called the circular system. In the circular system, you consider a full circle of 360 degrees and you look at it as one circle. And then you take the radius of the circle and you place the radius on the arc of the circle, and the arc that is equal to one length of a radius, you call that as a radian, 1 radian. So the radian measure can be described as the length here divided by the length of the radius. So we'll go more in detail of this as we go into the further chapters. But now, for this chapter, this would be a good introduction, and this is called the circular system, and the symbol that you will use to represent is C on the top. In this portion, we will look at how these angles are divided into 4 parts. An angle between 0 to 90 degrees is called to be in the first quadrant. So it's called the quadrant 1. And subsequently, the angles between 90 to 180 degrees is in the second quadrant. And the angles from 180 to 270 is in the third quadrant. And 270 to 360 is in the fourth quadrant. Great. So if I'm going to tell you 45 degrees, can you tell me which quadrant it is? Yes, you're right. It's in the quadrant 1. If I tell you 220 degrees, which quadrant it is? You're right, it's in the third quadrant. So it's quadrant 3. You can write it like this. Now, if I'm going to tell you 330 degrees, then it's in which quadrant? It's in the fourth quadrant. You're right. Quadrant 4. So, this gives you a short introduction to locate an angle in its right quadrant. Next, we're going to look at what are coterminal angles. So, before we go into that, I want to take you into this stadium. Okay, it's a circular stadium. Right. Now, you and I decide to go for a jog. So, you decide to take the call and you start jogging first. So, let's say you start from this point here. You see the red arrow. So, that's your starting point. And you go around the circle. While I'm sitting on the stadium and relaxing, having a cup of coffee, so you make a full round of the stadium. So when you come here, you have covered 180 degrees. Then you come here like this, you have covered now 270 degrees. Then you are coming back here. Now we have covered a total of 360 degrees. But I join you now and we both start to run together the second round. So we are running and we go round. So I pass the 90 degree with you and I cross the 180 degree with you and I cross the 270 degree with you and I cross all the way to the 360 with you. Now we both have run and we have come round to the same place where we started. So did we both run the same distance? No. I ran 360 degrees, but you ran 2 times of 360 degrees. So you ran 720 degrees. So the coterminal angle of 360 degrees is 720 degrees. So these are called coterminal angles. So if we had further crossed over and you had reached a 405 degree like this, somewhere here, okay, so one full circle has been run and plus an extra area has been covered. So how much is this? So we can define this as, so if it's 405 degrees, then you subtract it with a 360 degree, then you get 45 degrees further. So from the 360, this is a further 45 degree. So 45 degrees, which you can see here, the 45 degree and the 405 degree are coterminals. So 45 degree and 405 degree are coterminal angles. I hope this is clear. So for any particular point, if there are many rotations, then you can add those rotations and plus whatever is extra here, you can add them up and you can have a coterminal angle corresponding to it between 0 to 360 degrees. Then another aspect of this is negative angles. Instead of running in the anti-clockwise direction, which is in this direction, you decide to run in this direction. So now our degree measure should be measured in the opposite direction because you're running in the opposite direction. So since this is not the way we measure the angle is always measured in the anti-clockwise direction, and a clockwise run would be measured with a negative angle. So if you're going to run and cover this much distance, which is like a 90 degree from here, but in the negative side, So this angle will be called minus 90 degrees. Minus 90 degrees. Now you know this particular angle in the anti-clockwise direction, which is from the positive side, is 270 degrees. So when you come 90 degrees in the negative side, so minus 90 degree will be equal to 270 degrees. So minus 90 and 270 are coterminal angles. Similarly, the example that's given here is a 45 degrees here. So when you run in the positive side, which is anti-clockwise direction, it is 45 degrees, and when you do it in this direction, then it will be the negative side, so it's 360 minus 45. So how much is 360 minus 45? Will be a 5 here, so 1, so it's 315 degrees. Remember to put the degrees always. So if you're running in the opposite direction to reach this 45 degrees, then it's going to be in this direction, 300 minus 315 degrees. So that's what you have here. Minus 315 is equal to, or is a coterminal angle with 45 degrees, and 45 degrees is also a coterminal angle with 405 degrees. So I hope with this you will be able to spot or find or determine the coterminal angles for given problems. Let's get into some real trigonometry here. So consider the right angle triangle. So it's right angle at the vertex B. So if this is our angle theta, which is going to be our angle that we're going to use to find the ratios, trigonometric ratios, then the adjacent side is the side which comprises or which makes the right angle, and it's adjacent to the angle theta. So that's the adjacent side. And the side which is opposite to the angle theta is called the opposite side, and the third side is called the hypotenuse of the triangle. Sin theta is nothing but the ratio of this opposite side over the hypotenuse, and cos theta is nothing but adjacent side over the hypotenuse. Similarly, we have other ratios, trigonometric ratios, which are tan theta, which is sin theta over cos theta, and you have three reciprocal trigonometric ratios. So cosecant theta is a reciprocal of sin theta, which means it's 1 by sin theta. Secant theta is a reciprocal of cos theta, which is 1 by cos theta, and cot theta is a reciprocal of tan theta. Since tan is sin by cos, our cot will be cos by sin theta. And a gentle reminder of our trigonometric values or ratio values for 0 degrees. So when I say 0 degrees, what happens when this theta is 0 degrees? What happens when this angle is 30 degrees? And for 45 degrees, 60 degrees, and for 90 degrees. So for these the table is given where you have sin 0 as 0, cos 0 as 1, tan 0 as 0. These are the ratios. So when we say sin 0, so if this angle is 0, then the ratio of the opposite side by hypotenuse will be 0. Similarly, for 30 degrees, it is 1 by 2, root 3 by 2, and 1 by root 3 for sin, cos, and tan. And for 45 degrees, it's 1 by root 2, 1 by root 2, and 1 for sin, cos, and tan. Similarly, for 60 degrees, it is root 3 by 2, 1 by 2, root 3 for sin, cos, and tan. And for 90 degrees, it is 1, 0, and undefined for sin, cos, and tan. I have attached in the description box a very detailed list of videos of how these values are obtained, and at the end of this video there is a playlist on trigonometry which gives you a brief or a very good explanation of all the trigonometric ratios and a good introduction. So if you're very interested and you like trigonometry, then you could watch those videos and I'm sure that you will be benefited. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.